damos paso a Denis Janot. Él nos hará esta presentación. Os comentamos que va a ser una presentación que va a estar impartida en inglés y esperamos que todos la disfrutéis y que podéis aprovechar el día de hoy. Please, Janot, I give you the control of the presentation, so I'm finished my presentation right now. Thank you and good luck.
Thank you very much. And just before I start speaking English, you'll get a little bit more Spanish with Miguel, who will introduce himself very quickly.
Great.
Sí, hola, buenos días a todos. Muchas gracias antes de todo de participar a este workshop. Me parece muy importante y hay mucha gente que está siempre buscando información sobre Kubernetes. Muchas gracias a PUE por haber organizado este evento y no hesiten, como ha dicho Abraham, no hesiten si tienen alguna pregunta a volver para PUE o para Denis, para mí. Intentaremos de ayudar lo que podemos para intentar de hacer las cosas más comprensibles posible. Solo para vuestra información, hace 1 año y medio que estoy a trabajar para D2IQ y estoy encargado de toda la zona sobre la parte comercial. Solo para que estén más cómodos, si tienen alguna pregunta y que se sienten cómodos de me enviar un correo en español, no hay ningún problema. Bueno, que no tengo caso de cómo lo escribo en español porque no soy un experto en español, pero bueno. Muchas gracias, Denis, a ti fuerza.
Thank you very much, Miguel. So, hi everyone. I also want to mention that we have 2 other colleagues of us that are in the meeting. So you have like Alvin and Taco. So if you have any question, like we said, just ask them in the chat. They will handle them. If you can ask in English, it's better. Otherwise, Miguel will help them to translate, no worries. And probably if some of the questions are like things that would be interested for everyone, then they will probably let me know and I'll repeat the question in the video and I'll try to answer it at the same time. So let me share my screen and let's get started. Can you see my screen?
Yes.
Good, thank you. So yeah, I've already been introduced. So I'm a sales engineer working at D2IQ, a D2IQ that was known as Mesosphere before. So I don't know if you are aware of this change. A lot of people are surprised when we say that. So I just mentioned that quickly. And when we go through the presentation, I'll explain also a little bit more why we changed our name from Mesosphere to D2IQ. So the agenda is, after like a quick introduction about Cloud Native in general, we'll go through what are the different options available for running Kubernetes. Like, I can run that in Amazon, in Azure. I can deploy it by myself by just assembling all the components together. I can decide to use a solution from a vendor like us or someone else. So we'll try to give you an overview of the different options available and the pros and cons. Then we'll go through the same exercise for storage, because then generally when you get your Kubernetes platform ready, then the next question is how can I get like persistent storage? And then after that, when you start to use your Kubernetes platform, you start to have some needs for data services. So what we see a lot is like customers start by just like moving some traditional applications to containers, like G2E application. And in this case, they keep their backend like an Oracle database. So it's kind of a simple migration. That's kind of the first step in the container world. But then what they want to do is to develop modern applications. And when they develop modern applications, they don't want to use like an Oracle database. They want to use like data services like Kafka and Cassandra and so on. So we'll go through what are the different options for you there. Like I can run like a managed service in the cloud. I can run Kafka myself or things like that. So we'll go through what are the different options and again, what are the benefits of each option. Then also we'll speak about CI/CD. A lot of you probably already have like CI/CD platform in place. But here we'll go more into comparison between what are the advantages of using like your current CI/CD stack versus trying to adopt a modern stack that has been designed for Kubernetes. And finally, we'll go and speak about the day-to operation, which is very important. I mean, like how you are able to maintain the platform, how you'll perform the monitoring, how you'll centralize the metrics, how you'll handle data protection. So that's really like a huge agenda. We have 2 hours and a half, and that should be fine. So let's move on. So quick introduction about cloud native in general. It's not really easy to define this kind of term because everyone has his own like definition of it. So what I try to use is the ones from the Cloud Native Computing Foundation. So that makes a little bit of sense. And for people who don't know what is the Cloud Native Computing Foundation, perhaps you know it from CNCF. This is the way we call it generally. And the CNCF basically is a foundation that is part of the Linux Foundation, but that has been created when Google decided to open source Kubernetes at the very beginning. So they created this foundation to host Kubernetes, but then it became a lot more than that. And it's kind of now like the foundation that takes care of all the Kubernetes ecosystem. So it is hosting some projects like the Apache Foundation does, but it's also referencing a lot of projects that are not hosted by them. And it's like a good way for you to get like a good overview of all the different software and projects that are in this ecosystem. So we moved from virtualization to what we call cloud native, and it has not been like a straight move. You know, it means like you've seen some virtualization in the beginning of 2000, and then you started to see the cloud, and then you started to be able to do some very interesting things with PaaS platforms like Heroku or like Cloud Foundry, and it was really powerful. If you think about the way you use, for example, Cloud Foundry, it's really powerful. You just focus on your software development, but it's really limited at the same time. That means that it works well if you use like a language that is supported by Cloud Foundry with this specific version or this specific framework and things like that. So it's really powerful if you fit it, but it's not really open. And after that, you started to see the Docker emergence with the ability to containerize everything. And now with Cloud Native, we try to kind of mix these two things together so that you can get the ease of use of PaaS, where you don't care much about the underlying infrastructure anymore, but the ability to package that as a Docker container so that you can choose whatever language, whatever framework, and so on. So if you really look at the definition of Cloud Native, this is the one that the CNCF has, and I just put in bold like the most important things. Like it's really to build and run scalable application. If you have a very small application for 10 users, you don't need Cloud Native. You can do that in a very simple way, and it will be probably even more difficult if you try to make it like a Cloud Native way. Like if you want to split in microservices, like many functions of your application, if you know that it will never scale more than for 10 or 100 users, then there is no point in doing that. You can just have like a monolithic application. That will be fine. Another thing you see in Cloud Native is like this notion of public cloud, private cloud, hybrid cloud. So that's really something we see a lot. Like people want this portability, this ability to go from one world to another. Loosely coupled systems that are resilient, manageable, and observable. That means that you want to have like the ability to upgrade a part of your application with keeping the other parts unchanged, for example. Also, automation is really a key in Cloud Native, and also what we see a lot in Cloud Native applications is that you change them frequently. It's not like you come with a new version every 3 months. Is that each microservice kind of move independently, and they generally moved faster than they were moving before, because now you just have to focus on this small part, and the team that is responsible for it can move faster because it doesn't have to wait for all the other teams to move at the same pace. I hope it makes sense. What we see here is really a way to show how popular Cloud Native is now. And one way to see it is like the number of attendance in the different KubeCon since a few years. Unfortunately, the 2020 numbers will look really bad because the one in Europe has already been canceled, as you are probably aware, because of the coronavirus. So that will be a different story. But up to last year, you see the way it evolved, and you see that it becomes very popular. And basically now, if you ask someone like, oh, you can do only one conference next year about DevOps in general or about Cloud Native, what do you want to do? People would say like, oh yeah, I want to go to KubeCon. That really became like the go-to conference in the world. So the CNCF is also trying to make your life a little bit easier because this ecosystem is very broad, very complicated. So if you just start to be looking at it, it's quite intimidated. You can say, oh my God, like there are so many different components, so many different applications. So they try to make it easier to consume this information by kind of giving you like a journey to the Cloud Native if you want. So you start by containerization, you adopt like CI/CD, you look at orchestration platform, you start to put in place like some observability so that you can manage your platform, you look at the networking things, you look at the storage you can use, and so on. So it's kind of what they call this Cloud Native trail map. And if you remember what I described before, then you understand that what we are going to do in this meeting, in this workshop, we'll go through most of them. Not everything, because that would take really too much time, but we'll go really through a lot of these different components. So now, like as I said, let's say you want to deploy your Kubernetes platform by yourself, then the other way to look at it is with this landscape. So, and they started with this landscape only, and then they've added this map because this landscape is growing so fast that it starts to be really intimidating for people. So with this here trail map, it becomes a little bit easier to understand the journey you have to go through. But basically, otherwise you use this CNCF landscape, and you can see, you know, all the different options available for storage, for networking, for monitoring, and so on. And as I said, some of them are like hosted by the CNCF, and these are the big squares, but most of them are hosted by other foundations or they are just like software from other software vendors. So if you say, okay, I can do it myself, basically I can just like go through these different components, and I want to have a Kubernetes platform, so I'll go through the different options here, and I'll take like Prometheus for monitoring, and I'll take Elasticsearch for logging, and I'll take like Containerd for the runtime, and I will use M to package my applications, and so on. So you can build your platform by yourself. But what you have to understand is that Kubernetes itself is just this part here. It's just the core. Kubernetes alone doesn't have networking capabilities, doesn't have storage capabilities, doesn't have monitoring. That it's really just the core. So you have to integrate all these different pieces together so that you get what we can call a Kubernetes platform. And you can do it, but it takes time, obviously, because you have to learn about all these different pieces, and then you have to find a way to integrate them together and to make sure that they are working well. You can do that. It will take you 3 months, 6 months, depending on your skills. But the challenge is not really to build it, even if it's not easy. The challenge is really to maintain it, because imagine the number of new versions of each of these components you have every months or quarter. It's huge. I mean, like if you look at Kubernetes, you look at the Grafana new version, the new version of Prometheus and so on. We did a study last year, and in 6 months, you had like, if you take like the most popular components, because you know, I mean, like for monitoring, most of the people use Prometheus. For logging, most of the people use Elastic, for example. Then it has been like close to 200 new releases. You don't have to track all of them, obviously. But when you upgrade Kubernetes, for example, then you have to make sure that this new version of Kubernetes works with all the version you are currently using on these other components. And also, you have to manage the vulnerabilities. These ones, you don't have to apply all of them because sometimes you have a CVE that is not targeting your platform, but you still have to monitor all of them. And if one impacts your platform, then you have to put it really quickly in production. And you have to manage the interoperability of all these things. So it costs a lot more money to maintain your platform than to create it at the beginning. And that's really a key thing. And most of the people, they don't realize that before they are at that stage. Most of the people, they are going to this journey here, and it's only when they say, okay, now we are ready to go to production, then they say, oh my God, like how I'll be able to maintain this platform. So first, you need a Kubernetes platform, and you can do it by yourself. Some people will do it, but I would say 95% of the people will realize that it's not a viable option. So if you want a platform, then you can start to look at, you know, what Gartner says about it, what other people say about that, and you can see we are there. You can see Google, you can see Rancher, you can see VMware, you can see Red Hat. So we'll go through some of these options that are listed here. And we'll start by GKE. And the way I want to give you an overview of the different options is not by really using a lot of slides, but more by showing you that live, so that you get your own opinion about, you know, the user experience you have on these different things. Because for a lot of people, if we ask them like, what do you think is the best or the easiest way to run Kubernetes, they will say, hey, it's probably Google, you know, because they have been the one who have like started the project, and it's a public cloud. So I imagine that the user experience will be amazing, you know, and that's the purpose of this workshop, is to show you how it is, and you'll get your own opinion, and you'll be surprised most of the time by the different the user experience you get with these different options. So let me show you first Google. Okay. So you are on Google Cloud Platform. Let's say you get a login and you want to use Kubernetes. So you go there and you have like all the different services they have, and you have like Kubernetes engine, and you say, I want to create a cluster. Sounds good. So I want to create a cluster. I click here, and it tells me like what kind of location I want. Fine. It tells me about the version, and then you say, oh my God, like, by default 114. Okay, let's take a look at what is the current release, and you'll see that the community works on 119 alpha. Okay, 118 has just been released. Honestly, nobody will ever deploy like a .0 version of Kubernetes, especially it goes so fast that you don't really bother with that. So people who would start a project today will probably use 117, and people who are already in production will probably use 116. That would be kind of the normal way of thinking about it. And be aware that now that 118 is out, the community, the Kubernetes community, is working only on 3 releases: 118, 117, 116. That's it. Everything that is older than that, you don't get any support from the community. If you have a CVE tomorrow, a security issue, they will provide a patch for 118, 117, 116. That's it. So I go back here. I am in 114. Okay. I can do 115. That's good. I'm still not in a supported version. Then you can look at the release channel, and you have like a what they call a rapid channel. That is kind of a way to get like access to early things, so that you want to test before it's qualified for production. So that means that running this 1.16, which is the latest one that you should run, which is probably the most popular one currently in production, is not even something that they recommend for production use, because it's not in their channel that is stable. I mean, this is kind of really strange, right? But I wanted to highlight that because it's quite important to understand that the perception that you have about what you can do in the public cloud is sometimes not really the reality. You know, anyone would expect that Google would be the one that would be far in advance, and in reality, you discover that no, it's not that. It's not really the case. I mean, like, they are still kind of using older versions. So then you go to the different options. You have some nice features like enable auto repair and all these things. This is something that people like generally with the GKE approach, is that you don't really care about the maintenance. You just say auto repair, and you have one way you can say at what time you want that to happen, and it will just upgrade for you. So that's quite nice. And then you have networking. So networking is red here. So I need to find what's wrong. I don't know. You see, nothing is red. So you have to go click on create, and then, oh shit, still not red. So let me try to do something here. Yeah, now if I continue to click several times, and I get that legacy networks are not allowed. Okay, what does it mean? The network that the Kubernetes cluster is done, which disable network, you know, it's like you don't even know. So you have to go find, okay, how do I create a network? Probably you go to network service, you don't find anything, then I'll tell you I know it. It's here, VPC network. It's not straightforward because they don't even say VPC network here, they just say network. And then you have to create your own VPC network. And when you create your VPC network, you have to know, you know, the range, what you can use, what you cannot use. I won't go through all these things, but I just want to show you that it's not straightforward. It's not just like, give me a Kubernetes cluster, I want to play with it. It's like, oh my God, like I need to start to learn about how networking works in Google Cloud Platform before I can even start to deploy a Kubernetes cluster. So I won't go through deploying it because, I mean, I already did it before, so that I have one ready. And I'll show you now what is the user experience when you have this cluster available and you want to start to use it. So the first thing you would do normally is like you want to access the dashboard, you know. So you are looking for, okay, where is my button to access my Kubernetes dashboard? You don't have that. So you have this connect thing. If I go to connect, then, oh, I can see that I can configure it with the command line, but that means that then I need to have like this command line already configured, or there is something called run in Cloud Shell, which is good because then what it does is that Google provision for me a free virtual machine that I can use to be able to interact with my cluster. So instead of having to configure the gcloud CLI on my laptop, I can just do that. And then now I can do a get nodes and I can see my cluster, which is good. One thing you have to realize here is that I only see my workers. And that's one of the major problems you have with the public cloud, is that they show you only the workers. You pay, or you were paying only for the workers. Now they are changing that. You start to pay for the control plane in AWS, and you will start to pay for that in Google Cloud in June. But you don't access the master. So if you start to deploy some containers and you have like one, I don't know, the container doesn't deploy or something's wrong, normally you have to go to the masters and look at the logs. You cannot because you don't have access to the master. Anyway, let's go back to what we wanted to do. Normally, when you want to access the dashboard, then you have something called kubectl proxy. And normally you have now to access this port, 8001. But the problem is that I'm not on my machine. I am on this VM here. So there is a web preview feature that allows you to preview, but it's not this port. And if you change the ports, you cannot change the port to 8001. I think in the past you could do that. Now you cannot. But even if you can, then you still have to learn about what is the URL for that. So kubectl, dashboard, URL, and then you look at this documentation, and they tell you that to access the dashboard, and the URL is that one. So you are supposed to use this full URL. Obviously, I cannot now because I cannot access this port. So I just wanted to show you that, okay, it's not that straightforward. I mean, like, I was expecting something like the first time I came to GK, I was expecting like, okay, show me the dashboard, So quite difficult to use. They have replicated some of these dashboard features in the console directly, but it's only a subset of it. And you don't really want to use something that is proprietary. You want to use like the standard dashboard, So that's something that is a little bit complicated in my opinion. It should be a lot easier that you get the dashboard button, you access the normal dashboard, and you just manage it normally. You also have like the ability to deploy some applications from the marketplace, which is quite nice because you see, if you want to try out a new technology, it's nice because you don't have to bother about going through finding documentation about how to deploy this or this technology. But if you want to go in production with that, no, it's not something you will do because you don't get any support. And even if without just having this support issue, it's really basic. I mean, like, let's say I want to deploy like GKE, logging, Elastic, then you cannot really configure many options. You have like the namespace and the number of instances. You cannot even change the version of Elastic or things like that. So it's pretty basic. It's not useless. I mean, it's useful if you want to try out the technology quickly, but it's definitely not something you'll use for production. So at the end, you still have to go through finding by yourself how to run these different applications on Kubernetes. But that's good because we'll go through that later. So let me go quickly through the chat to see if there are some questions or something that, yeah, I think what I'll do is that, yeah, I mean, like Alvin or Taco, don't hesitate to speak if you have some interesting question, and you just don't hesitate to interrupt me and ask me the question, and I can cover it. I think it will be easier that way. So let me go back through this and make sure I didn't forget anything. So we spoke about that. So when I was doing the slide, it was like 2 months ago. The default version was 1.13 at that time. So now it's 1.14, which is a little bit better. But I told you it's still quite far away. We spoke about these different options that you have. This one, I spoke about it. I didn't show you. I quite like it. It's like the ability to define a maintenance window so that you can set when the cluster is upgraded or not. We spoke about these applications you can deploy and how difficult it is to access this, to connect to your cluster, especially if you want to just access the dashboard. So now let's go to EKS, which is, you don't expect it to be the best for Kubernetes because they are not like Google, the ones who were behind it at the beginning, and they are not really well known to participate in open source projects. They are more like packaging them and making them easier to consume for the end user, and make them a little bit proprietary. That's more the way they work, but they are the leader in the public cloud, so you expect that they have probably a quite good Kubernetes offering as well. So you go there, EKS, and you say create a cluster, and you give a name of a cluster, you don't care. And you see here, again, quite depressing, right? 1.14, you can do 1.15, you don't even have a preview on 1.16. So I would say it's even worse than Google. It's quite similar, but even worse. They have absolutely no version that is currently supported by the community. Then you go to role name, and now, oh my God, I have to know what does it mean, you know? So I have to go in this link. It gives me the UI of another service that is called IAM. Then I need to create a role, and then I need to create a role for EKS. So I should be able to find it somewhere, EKS, and EKS here. Next. So at least it's not too complicated, right? It's quite bad that I have to do it manually. It would have been better if I can just tell Amazon to do it, but at least it's quite straightforward to do it. I don't have to be an expert on Amazon to do it. I have already one, so that's fine. Now, oh, it asks me for a VPC. Again, this networking thing, I don't get it. Like, why in a public cloud, it doesn't do that for you? I mean, like, if you are an expert on this technology, that makes sense because you probably have some specific network design. You want to make sure you do that in a special way, but you should have a way to have like a basic one, like a secure default networking or whatever, you know. You don't have that. So you have to click here, and then you have to create a VPC network. And again, that means that you have to be able to answer many questions that you are probably not sure about the implication about all these things. But let's say you create your network here, and finally you go there, you select your network. Let me try to find one that is that will be like a default one. No, this one is good as well. Yeah, let's say this one. Let's say I would have created a new one. I would have something like that. Okay, so I would just click on that. I will take the default group, and I would say I want to have like the logs centralized, for example. Then I would create, and then you will tell me what? Oh no, you need to have at least 2 AZ. So then you would have to go back on, you know, this subnet screen, and then you will have to find how to add a subnet to your VPC you created before. I will not do that, okay? I'll just show you, you know. So it's not straightforward, right? Again, like I mean, I'll just tell you from what I've seen when I started to build this workshop, I was expecting something a lot easier. Anyway, I have already one cluster running. I did it before. So let's have a look about the user experience in this case. I mean, I don't have access to the dashboard again. No. I don't have a connect button telling me how I configure everything. I don't have a marketplace. I mean, like, it's probably the worst user experience you can expect, you know. So now if I want to connect it, I need to say AWS, EKS, configure kubectl, for example, and then you'll go there and you'll find out that you need to run this command. So it's the equivalent of what Google does, but here you don't have a shell. They don't show you that in the main UI. You have to find by yourself on Google. And you don't even have access to anything else. You don't even have like a part of the dashboard here. So it's quite basic. The other thing that you can do is that you can get logs. So they have like centralized logs. Again, it's a log service from Amazon. So you have to learn about how to use this service. It's not very complicated, to be honest. But also you have to understand how much it costs, because, you know, each service in Amazon has a different billing strategy. So you will have to pay for these logs. You will have to pay for X, Y, Z. So you have to be a little bit careful. So if I go back in the slides, this is what I've shown you, like really not straightforward at all to deploy a cluster. The way you get the logs, again, being careful about the fact that each service has its own billing, and you have to go online to even know how to access it. So then when I started to prepare this workshop, I said, okay, Microsoft for Kubernetes. You feel like, no, it's probably not the one that has the best experience. You know, even if Microsoft is working very hard on open source since several years now, you don't expect them to have a better experience than Google, for example. So let's go to AKS. So this is like the Azure console. And now let's say I want to create a new Kubernetes cluster. Okay. So I click on add. I am not sure what is like a resource group, but that's fine. So the first good surprise that by default, it's 1.15. It's still not a supported version from the community, but it's just by default. And 1.16 is not in preview. It is supported. Means that I can go in production with a version that is supported by the community. I cannot with Google. I cannot with Amazon, but I can with Microsoft. And I can even do the preview of 1.17. So that's quite nice. I mean, like it's a first good surprise. And then you can change the node count. I think it would be easier if here they give you like some information about the CPU and memory, but you can get it quite easily if you click here. And then you can say, do I want to use VM scale set or not? I mean, they explain it like here, but it's not really easy to understand, you know, for variety of scenarios. So if you don't know, it's a little bit confusing, but at least I would say what's good is that I can click next, even if I'm not sure what it means. It's not always very clear if I need or not an option. I can get my cluster up and running very quickly. Okay, so that's, I would say, a big difference if I compare with the other ones. So I have a cluster already deployed, so I'll show you here. And the other good surprise that you see, you have a real dashboard, you know, like I don't have to go for my logs. I don't have to go somewhere else. I don't have to find, or I am not redirected to another service. Obviously, I will need to learn about how to use this log service from Azure. I'll still have to pay for the logs like for Amazon, but at least what you can see is that it is quite well integrated. I get also metrics from my cluster and what they call insights. So it's really far better than what you see in the other cloud providers. Okay, I can see information about my nodes, by my controllers, my containers. Still, I mean, like it's impressive if you compare to the others, but it's not very deep. I mean, it's still really, really basic metrics about, you know, just your containers. You don't have information about your storage, about your network, about many other things, but still it's a lot better. You also have like the integration with the CI/CD services here. So again, there are other services from Azure. You have the equivalent services on Google. You have the equivalent services on Amazon. But here, at least, they are shown in a way that is quite easy for you to find them because it's the same UI. So I would say the user experience is far better than what we've seen in the other clouds. Still, you cannot really access the dashboard, which is still a big problem, in my opinion. You still have no way to understand how to configure kubectl. So you still have to do like configure kubectl Azure. So again, I mean, like it's not straightforward. I won't go through the details, but and I mean, like here's the goal. You know, you deploy Kubernetes is just you want to use it, right? Otherwise, there will be no point. So now you can deploy Kubernetes. You have a better way to manage it, but you cannot still use it easily. So that's still a problem in my opinion. Going through some slides again. So we've been through all of these things. So nothing special. And this is the way you connect to the cluster. So with this AZ CLI. So we looked at like many options for like the public cloud. Then you can use other software that allows you to deploy Kubernetes on-premise. or in the cloud. And we'll go through Rancher as one option. So I'll show you that here. And I have one cluster running, and I will be able to deploy a new one as well. So let's say I want to create a cluster here. I have some options. I can deploy an EKS cluster, which doesn't really help much because you can do that in Amazon as well. Or you can deploy on EC2, which means that it will be what we call a RKE cluster, so Rancher Kubernetes Engine. So it will use VMs, but it will deploy the Rancher Kubernetes version. So if I do that, then I want to call it whatever. Then here you have to create a template. So you put your credentials, I already put them. And then, oh my God, again, they ask me for a subnet and a VPC. So that means that I, again, need to go to my Amazon VPC UI and do everything by myself, probably going to some documentation from Rancher that explain me what I need, if I need several availability zone or not, and all the things. So again, really painful. I mean, like you want an easy option and a quick button to press to get your cluster up and running. And up to now, we've been able to do that with Azure. It didn't ask us all these complicated things, but we had to do these complicated things with AWS, with GKE, and now we have to do that again, even with a software vendor, so with Rancher. So let me just select one. Same security group, at least here you can get one by default, which is what I would expect for the network as well. So here you can select, you know, the kind of machine you want, which is quite good. You can give a name to your templates, and you can customize a few other things. So then you say, okay, I want, let's say, 3 masters and 3 workers, because what we've seen in the cloud, I've shown you for GKE, but it's true for the other ones as well. You don't have access to the master, which is an issue. To do troubleshooting and so on. Here you can have the masters, but how do I do that? Like, you know, it's first time I've been through that and I've seen these things and whatever, I was really confused. If someone tells you how it works, that's okay. But the first time it's not intuitive. How I define, I want to have 3 masters, 3 workers. So at some point you finally discover you have to go there, you have to do something like that. And then you have to choose the template you created. And then you have to put that and that and that, for example. And it's a little bit weird because you can do that, for example. You could say, I want my etcd to run on my workers, which makes no sense. But anyway, after some time, you make it green and it works. So it's not really intuitive, but that works. In terms of versions, it's far better. What you can see here, you'll probably select something like that, which is like the one that everyone kind of gets in production today. But you see, it's quite good. 116, 117 are supported by the community. Network provider, Canal is definitely not the most popular one. Calico is. Canal has some advanced features like network isolation. So you have pros and cons, but I would say Calico is a lot more stable and it scales. Canal doesn't scale. So if you really need network isolation, perhaps you will do that, but I mean, it's definitely not the most popular option you would see in the market. Then you get some other option. I won't go through all of them. So when your cluster is ready, you get something like that, a very basic dashboard with no real metrics and so on. But usually you have this enabled monitoring. And what happens if you do that is that it will deploy for you Prometheus on your cluster. So that's quite nice because now I'll be able to have more information. So it's not ready yet. We will let a few minutes to have that ready and we'll see what it provides. You also have like this kubectl here, which I really like. You can say get nodes and you see your node. You have access to your control plane as you expect. So this is quite good. I mean, like it really allows you to quickly troubleshoot something on this cluster. And if I want to configure kubectl, I can do it right here, you know. So I can download here if needed. Oh, it doesn't work. It was working in the previous version. Looks like it is broken. They probably made a mistake in the link. It's not supposed to be this link. It's supposed to download this file. That was doing that before, not anymore, but just a small bug. Not a big deal. You can do like copy and paste on this in your kubectl and you're fine. So I find it's quite nice. I mean, it's a nice way to configure your kubeconfig. Now we have like the metrics, but what about the logs? So if you go to tools, not tools, yeah, I think this is a little bit confusing when you have the cluster view and the global view, and then you have different options if you go from one or another, you know. So I am on the global view. If I go to the cluster view, then it's here logging. Sorry, I missed it. So here you can say, oh my God, like it's perfect. I have so many options. I can have Elasticsearch cluster. So, oh no, okay. It just tells me that I can send my logs to Elasticsearch. So it's good. If you already have Elasticsearch or Splunk, it's good and it's straightforward to integrate. If you don't, then you will have to find by yourself how to deploy and manage Elasticsearch in your Kubernetes cluster. So it's not really ideal in many cases where you just want to have your Kubernetes platform that has everything integrated. Like they did for Prometheus, you expect that they would have Elasticsearch deployed on the cluster, but they don't have this option. So now that I have the metrics, I have a better dashboard. I have like some metrics here. It's a little bit similar to what you've seen in Azure. It's not that advanced. Huh? It's not really providing like tons and tons and tons of metrics. You see, you can click and you can access the dashboards, and you get some metrics. As I said, quite similar to the metrics you get with Azure. Not much, but at least you get some metrics. And there is also this new dashboard option that they just released, and they ask you if you want to try. I looked at it. I'll be honest. You get some good information that you were not getting before in the dashboard, but I've not been really impressed by the look and feel and so on. It's like more like a listing of things, you know, that you could get from kubectl and that now you get that way, you know. So I mean, I don't know exactly what's the purpose of this dashboard, but anyway, oh, I closed it. So let me reopen it. So again, I mean, like what RKE provides is a way to have like a Kubernetes cluster on-premise or in the cloud. You get recent version and you get some metrics, but there's not like much more than that. But what made Rancher quite popular is more like the ability to manage these projects and permissions. So you can say, I am on this cluster, you know, on this cluster view, and I can create a new project. And in this project, I can create a name. I can add a namespace. So I can say, I want project 1, and then I can apply permissions to that. So I can say this person has this permission, you know, like one is project owner, one can be just like a storage admin, or so I can add a namespace and it's one here. I can do put some limit on it, which is quite good. And if I am here, then I don't remember exactly how to do that, but anyway, there is a way to apply the permissions, which is quite good. So you can add members here, then you can manage, don't remember if it's in the global view. Yeah, you can create, you know, you have roles like being able to do this and this and that. So you can say, okay, this person is more like a storage admin, can only create storage classes, and then you go on the cluster view and you select the project and you add this person as this role. So it's really good because it's difficult to do with the kubectl command line or the API. So that's really what made, I think, Rancher quite popular. The only limitation of that is that you have to do that cluster by cluster. So if you have 1 or 2 clusters, it's okay. If you start to have 10 clusters, then you have to create the project on each cluster and then apply the permissions and so on. So that was a good overview of it, I think. I've shown you most of these things. Oh yeah, I didn't show you that. So you also have this ability when you're on the global view to go to apps and to launch a new app, very similar to what we've seen in Google Cloud. Again, it's good if you want to try something, but it's not like for going in production. There is no support for any of these things. And basically what they do is that they do like a wrapper around Helm. So it just deploy mchart, but they kind of just create an additional file that describe the Helm options so that you have a UI for it. But that's it. And then they are just the open source Helm and doesn't provide. So it's nice for the user experience, but it's not really for going production. Again, it's good if you want to try something out. That's it. So we went through that. We went through this nice thing. So then you have another option from us, obviously, that we call Convoy. And the way it works is that you can deploy a cluster from a UI like you've seen in Rancher, but you can also do that through the command line. So it depends on what you want to achieve. So I will show you the 2 options so that you have an idea. So here, you can download the Convoy command line, CLI, and then you can do Convoy init, and it will create a cluster.yaml file like that, where you can say, I want to use AWS with this region, and everything is by default. I didn't have to write any line of code. What I do is that I do Convoy init, it creates everything for me. I can just change the region if I want, or the provider. I can, change the number of control plane or workers, and then I can specify which add-on I want to deploy. Like I want Prometheus, I want Elasticsearch, I want XYZ. So by default, you will have the full stack, and you can remove some of them. If you prefer to use your own Elasticsearch cluster, then you'll be able to disable it here. Otherwise, it will be deployed for you. Then you do Convoy up, and you get everything deployed automatically. And behind the scene, we use like Terraform and Ansible, and you get something like that. So first of all, it's a lot easier because there is no notion about creating your own VPC and subnet and all these things we said before. You can, if you want to create your own, you can override that in the cluster.yaml. But by default, we will just create one for you. So without any knowledge about AWS or Azure, whatever, you can get your cluster ready. Then when it's ready, again, I want to access the dashboard. There is no like complicated way, you just go and click on dashboard and you get your Kubernetes dashboard. I mean, like it's just like what you would expect from any cloud provider, to be honest. And I'll go through all the other things you get on the stack. You get Grafana deployed with a lot of metrics. You get like Kibana, you get like Elasticsearch and traffic. All these things are already there by default. I will go through that when we will cover the day 2 operations. I won't go through that now, but I just want you to see that, okay, we have all these dashboards already ready out of the box. But then if you look at things that are more similar to the Rancher project or the ability to deploy new cluster from the UI, this is what we call Commander, okay? So you can just click here to get access to it. And you have this notion of clusters, workspaces, and so on. So I'll go through that very quickly. So here, you can see your different clusters. I have 2 clusters, the one I deployed first, and then from here, I deployed the second one. If you have many clusters, then you can get a list so that it's easier to see the current usage and the current version and so on. And then if I want to create a new cluster from the UI, not from the command line. Either I can attach an existing cluster, and this is something you can do with Rancher as well, by the way, or I can create a new Convoy cluster. And here I can select the version. So we support 1.16, which is supported by the community. We have like a new version even of it that support 1.16.8, and we are going to release 1.17 very soon. Then you can say, I want this cluster to be called cluster 2, for example. I want it to an AWS, but you could select another provider. I just have AWS in the list because I put my credentials for AWS, but I'll show you that you can do that for anything else. You can select your region, and by default, you see it's straightforward. You don't have to, it's really intuitive. I want like 5 workers, I just change that to 5. I want like bigger machine, smaller machine, I just choose it. And I don't need to go through complex network configuration, VPC, and all these things. You see, it's a lot easier. Now, if you want to do something very advanced, you can still upload your YAML and put all the options you want, like the one that you have on the cluster.yaml. So that's the way you deploy your cluster. And then when you have your cluster ready, you see you have the experience that is similar to the one I've shown you before for each cluster on Convoy. You have the same experience here on Commander. And if you want to look at something like applying permissions, something similar to what you have seen with Rancher, here the way we do it is that we have two notions. We have one notion of workspace, and in one workspace I can put multiple clusters. So I can do one workspace for business unit 1 with 3 Kubernetes clusters, one workspace for business unit 2 with 2 clusters, for example. And then in one workspace, you can create what we call a project. So you can say, I create a project 1, and I want to associate it to the cluster 1. And I can associate to many clusters. I have only one here, but I could say cluster 2, cluster 3, for example. And then what it will do, it will create a namespace, a unique namespace automatically. I don't have to go and create a namespace by myself just after. And when this project is created, it gives me multiple capabilities. One is I can create a policy, or I can create roles. So I can say, very similar to what you've seen before with Rancher, now I can say this person is a storage admin for this, or storage admin for this project doesn't really make sense, but as this role for this project, and it will be automatically applied on all the clusters. So I don't have to go on each cluster, create the project on each cluster, and setting the permissions for this project for each cluster. I just do that at the project level, and it will be applied to all the clusters. And give me some other nice capability, like I want a config map to be created on all the clusters in this namespace. I want to have secrets created automatically for that. And I can even say, I want some services to be deployed like that. I can add my own services. I can add any Helm chart. But here you see some of them are called certified, and I'll go through that later. But basically, that means that they are ready for production, and you can get support from us. And I'll cover that a little bit later. I just wanted to give you a quick overview of Commander, which is quite similar to the idea of Rancher, but with this multi-cluster management that is pretty unique. And as I said, you can add multiple clusters. You can do many nice things. So if I'm going back to that, the idea of Convoy is really that we have assembled together the most popular projects that you can see in the CNCF landscape, like Prometheus and Grafana for monitoring, Fluentbit, Elastic, and Kibana for the logging, Velero for the backup, MetalLB for load balancer, like traffic. So we have assembled all these things, and you get everything supported, qualified. You don't have to spend time about integrated everything. You don't have to spend time about maintaining it because we do everything for you. But at the end, the user experience is the same as if you would have done that by yourself, because you will access the Grafana dashboard, you will use Kibana, you will use the traffic UI. So it's it's a certified, but still an open platform. And then Commander, we spoke about that, being able to deploy multiple clusters in multiple clouds or on-premise, being able to apply permissions across these different clusters, and doing much more in the future. So that's kind of the first step, you know. What you wanted at the beginning is I need to have a Kubernetes platform. Now you have different options. We've been through them. And the next step is what we discussed before, like storage and monitoring and data services, and we'll go through that. But to go through that, we'll go through a demo. So that's, you'll see all of the different pieces in actions. So we spoke about Commander, we spoke about Convoy. You will be introduced to Kudo and Dispatch, that are other products that we have built in the next sections. But I just want to introduce this demo that we'll go through, because the idea is that we want to have like the ability to deploy a Kubernetes cluster. That's what we do here. We want to have the ability to have data services. That's what we will do here. We want to have the ability to have like a CI/CD in place, modern CI/CD. That's what we will see here. So the idea of this demo is that we will have a CI/CD platform that will deploy several microservices, S1, S2, and S3. This microservice will get pictures of sunset from the Flickr API, and we store them in an object storage cluster, min.io. Min.io will notify Kafka when there are new pictures uploaded. The second microservice will listen to the Kafka topic, so that every time there is a new picture, it will be informed, and it will extract from these pictures the GPS location, and we store all this information in Cassandra. And the third microservice will get the information from Cassandra and will be the front-end service, if you want. We'll expose that in the map. So we'll be able to show you CI/CD, data services, everything in one demo. So what we have done so far is just deploying Convoy. So that's where we are. Now we'll go through learning the different options one by one, and we'll continue to build the demo at the same time. So we have the Kubernetes platform. Now, next step, I need persistent storage. Why you need persistent storage first? So first you need that because if you just like use the standard storage and you just use the storage of your containers, and the worker where the container runs is lost, for example, then obviously you lose your data. So that's not what you want. You want to be able to have like high availability, and you want to make sure that if you lose this worker, then your containers, your pods can be restarted on another one. If it's a stateless pod, then it's not a big issue. But as soon as it's stateful, then you need to have like persistent storage. But also, sometimes you look at persistent storage for other things, like you want that to have the ability to share data between your pods or for snapshots, for example. So if you are in the cloud, you can, just give me 1 second. I'll ask my keys to make less noise because I'm working from home since like you, I think. Okay, sorry, I'm back. So if you are in the cloud, you don't really care about this persistent storage. It's here by default. I mean, like if you are in AWS, you can use EBS, for example. So if you just want to use Kubernetes in AWS, either using EKS or using Convoy, you don't care, you can use EBS. But if you want to deploy Kubernetes on-premise, then you need to have persistent storage. Or if you want mobility between on-premise and the cloud, you also need something else. So there are many options. Again, you can go to the CNCF landscape. You can look at all these different projects, and you can find out what makes sense for you. The two most popular options we see currently are like OpenEBS on one side. This is like, I would say, the most popular open source option. And you have like enterprise version that give you more capability, especially in terms of management. And And then you have Portworx, which is not open source at all, but which is probably the most popular software for storage, especially because it provide like better performance. And I will go through the demo with Portworx, but we work with several partners. We work well with OpenEBS. So the guys behind them that are PUE DATA. We work well with Portworx. We work well with Hedvig. We work well with many different vendors. Before we go to the demo, a few concepts that you have to understand. So one is this notion of volume and persistent volumes. And generally, when you start to look at storage in Kubernetes, you are looking at, okay, how do I create my persistent volume? What is the command line for that? What is the YAML that I should use for that? And quickly you find out that no, it doesn't exist. You don't do that. What you do is that you create a persistent volume claim, which you can think about that as a request. This is a request for storage. I request 10 GB of storage. So you create this request that's called a PVC, persistent volume claim. And when you attach this to your pod, then the persistent volume is created by Kubernetes and is attached to your pod like you see here. The other notion that is important is this notion of storage class. Generally, what you want is to have a default storage class in your cluster so that anyone who wants to use persistent storage doesn't have to ask any question to anyone else. He will be able to access persistent storage. But if you have several kinds of persistent storage, several software vendors, several platforms, or several type of storage availability, or several type of storage like SSD and slow disks, then you can use storage classes to define different classes that can be consumed. So what I did here for the demo is that I already ran a few commands to deploy Portworx. So first of all, I went through using the AWS CLI because I deployed my Convoy on AWS. I used the CLI to create one volume for each worker. So it's just like to simulate like if I would have on-premise and I would have one disk attached to each worker. And then I just deployed Portworx, okay? So I just deployed Portworx and that gives me access to this UI. And I can see I have 5 workers, so I have 5 nodes. And if I go a little bit deeper here, I see I have 5 drives, so 1 drive for each worker. What I didn't do yet is creating a storage class. So I will create a storage class with this parameter replication equal to. That means that I will have 2 copies of my data when I will create a volume. So I create a volume, it will be attached to a pod. There will be 1 copy where the pod runs, so you get really good performance. And then there will be a second copy in another worker. You can change that. You could have several storage classes, one with 2 copies, one with 3 copies for different availability, for example. So I'm going to create this storage class here. And what you can see, I want to show you here quickly. If I go to storage classes, I already have this AWS provisioner. So if by default, when I deploy something, it will use EBS storage. And I have this one that has been created by default by Portworx, is just if you want to use snapshots. So I'm going to create this new storage class, Portworx SC. And then what will happen is that I'll be able to see it in my UI. You see I have it here now. So then what I want to do is that I want to send some metrics to my Prometheus instance that runs on Convoy. And there is something called service monitor. It's very interesting when you use Prometheus and Kubernetes, is that when you create service monitor, basically it allows you to configure the way the metrics will be stored in Prometheus and gathered by Prometheus. So by doing that, I ensure that I'll get all the metrics in my clusters. And I will show you then how you can access that. I will show you that when we go through the day 2 operations and the monitoring parts. So I have now that ready, and we are going to use storage to go through data protection using snapshots and so on later. So I won't go deeper now. I won't start to consume storage now. I'll go through the next section, and then I'll show you how the storage is used in each of these sections. Okay, I hope it makes sense. So now we have like Portworx running on Convoy here, so we will be able to consume it. The next step, now that I have persistent storage available, is that I need some data services. So why I need data services? As I said, if you just take a G2E application and you move it to Kubernetes and you keep your Oracle database, you don't care. But that's not what you want for your new applications. For your new applications, you want to use things like Apache Kafka for exchanging data between your microservices. You need things like Cassandra to store your application data. You need things like Apache Spark if you want to do some analytics of your data. You want things like MinIO to store unstructured content. So you have many, many examples where you need like data services, modern data services that can scale and that are way cheaper than Oracle, by the way. So let's take the example of NoSQL. You want NoSQL in the cloud. So what can you do for that? You can use something like DynamoDB from AWS. It's simple. I mean, like, I don't want to spend my time learning about how to deploy a NoSQL database. I don't want to maintain it. I don't want to upgrade it. That would be too difficult. Let's just go and use like something like DynamoDB. So you go and you look at DynamoDB pricing, and you find out that you pay for many things. And you pay for storage, that makes sense. You pay for compute, that makes sense. What's a little bit strange is this way of paying per request. Because I tell you, if you ask now your developers, like how many requests you will send for your application, they will say, I don't know, I have no idea. Like, how can I know how many requests I will send? I mean, it depends on the number of users. It depends even on the choices I will make when I develop my application. Perhaps I will find that it's better to send big requests. Sometimes I will find it's better to do small requests. The most important is the user experience at the end, not like the pricing. So it's very difficult now because you kind of have to tell your developers to develop in a way that will ensure that you don't pay too much because of the way they develop it. So that's a big issue for many people. You have other options on other clouds. Like if you're in Google Cloud, you have the equivalent with Cloud Data Stores. Again, you see you pay for the requests. You have Azure Table Storage, equivalent of the other one. Again, you pay for the transactions, and you pay for like data transfer. You pay for all of these different things. So it's very difficult for you to know in advance how much you will pay. So what you see that the other problem you have is that it's proprietary. So it's not like something like Cassandra or Mongo. It's like each one has its own option, which is proprietary, which has different features and so on. And the pricing is complex. So you could say, hey, I can look at something else. Someone told me about this managed Cassandra service. So I have something that is like open. It's not like a proprietary option from AWS. It's kind of an open source Cassandra, but it's managed for me. So it's cool. It's what I want. I mean, like I don't want to do that by myself. So you look at it and you say, okay, if there is a managed option, I imagine I will pay for the virtual machine behind this service, like the EC2 machines. So I'll pay for the compute, I'll pay for the storage, and okay, I'll probably pay an extra cost for the management. That will make sense because they do it for me. But no, still ask me to pay for requests. So I still have the same issue again. So it doesn't solve my problem at the end. I want to have something open, but I also want to have something that I know how much it will cost me. And there you go. So you cannot do that way. So what you can do, and also we spoke about the cloud, but what if I want to have that in my data center? I have no option for that. So that's why a lot of people started to say, okay, we should have a way to run these things on Kubernetes directly. But if you just look at using the standard objects like deployment and pods and stuff like that, then you have a lot of things that you cannot do and you cannot describe using these standard Kubernetes objects. Like you cannot define the way you do backups or how you do an update with some checks in the middle or things like that. So that, and you cannot have dependency, or you have like a lot of things that are like missing there. That's why people started to come with this idea of operators. So we'll create a pattern called operator that will allow people to describe how to deploy and how to maintain a complex distributed application, like Cassandra, like Kafka, like all of these things. So from this, you have now, let's say, 3 main implementation of the operator pattern. One is the one from Red Hat that came from CoreOS, which is based on a lot of Ansible. So that's the good thing on that side, that other people know how to use Ansible, so they feel that they can use this framework because they will be able to reuse their knowledge of Ansible or Helm. But very quickly, when you want to do some stuff advanced, you have to switch to Golang, and you have to do a lot of things in Golang, which is not really easy. So that's one option. The second option is the one from Google, which is pure Go. So at the end, if you want to do that, you have to know Go. They make it simpler for you because they give you templating and things like that, but still, it's not straightforward. And then there is another one that we have started at D2IQ more than a year ago. That's called Kudo, and we have donated it to the CNCF. And it's kind of now the preferred option if you want to build an operator on Kubernetes. And the beauty of it is that you can describe everything with YAML. And I'll show you that in a minute. It's really straightforward. So the other good thing is that there is a unique controller for multiple options. So with the other operator frameworks, you create your own controller for each operator. So it's more difficult to maintain, it consumes more resources and so on. With Kudo, you have a single controller, and then you describe your different operators in YAML, and this controller is deploying them and maintaining them. So you have already multiple operators available. You have Kafka that is GA. I should have updated this slide, in fact, because here Spark is GA as well, and Cassandra is still in beta. So I'll go through that, but everything is open source. So Kudo is open source. These operators are open source, but we give you the option, if you want to get support, we provide full support for them. And that means that support of the operator, but support of the technology as well. So if you want to run Kafka in production in Kubernetes, then you come to us and we give you full support of the Kudo operator for Kafka plus Kafka itself. And the same for Spark, and soon the same for Cassandra. And there are others like Kudo open source operators that are also available. So the idea here on this demo is to deploy Kudo Kafka and Kudo Cassandra. But you see there is one difference between the two. One will use the standard persistent storage, so it will use EBS, and one will use Portworx, so that we show you some advanced capability later that you get with Portworx. So I'm going to go back to my deployment here, and I'm just checking that I set these variables in this shell here. Yeah, I do. In fact, if you see all of them, that makes no sense to put it secure. So here, I just check that if Kudo is already deployed, it will just uninstall it. And then to deploy Kudo, you just run this command. It's an extension of kubectl. You see, you don't have to have a special CLI, it's just an extension of it. So you do kubectl Kudo in it. So you just have to download this extension, and then you do that, and it will deploy Kudo for you in your cluster. And you will get your controller ready. And then I want to install Zookeeper. You see kubectl Kudo install Zookeeper, and this is the instance name and the version of the operator. And you see for Kafka will be the same, but Kafka, and you can specify some options, and the same for Cassandra. So as I said, because you have a single controller, the user experience is the same, whatever you try to deploy. And here I can check the status of the deployment, and you see it's very interesting because you have this notion of deployment plan, phases, like I deploy Zookeeper and then I validate that Zookeeper works. And if I look at the pods here, I see that it has already deployed them, but they are not ready yet. So that's why if I look at the plan status, it's still in progress, and you see the Zookeeper phase is done, but the validation phase is not yet. If I look at the pods, the validation phase is a job, in fact. Okay, so I'm just going to start deploying Kafka, and at the same time, I'll show you how these operators are built, so that you see how easy it is to do that by yourself. You can create easily your own operators, because, as I said, it's just like pure YAML where you'll describe the different plans, the different phases, the different steps, and you'll be able to get this kind of experience at the end. So you see it's complete. Now I can deploy Kafka. The difference here, I also specified some parameters here. But I'll be able to follow the deployment of Kafka the same way. And if I go to operators here, and I look at Zookeeper, for example, I can see, the version of Zookeeper corresponding to the version of the Kudo version. And if I go to this directory, I see a param file that are all the options I can set with the -p option. You see like the storage class, the size of the disk, the memory, or things like that. So very straightforward, described in YAML. Then I have this operator YAML, which has the full logic. So like I said before, there is a plan that's called deploy, with a strategy to do that in series, not like everything at the same time, but you see the first phase, which is deploying Zookeeper, is in parallel, and it involves these different tasks. And then here you define for each task what are the YAML manifests associated to the task. So then you go to the template directory, and you see, for example, to the validation phase, as I said, is a job, and this job is just described here. So you can really define the logic, the complex logic, easily in YAML to have your operator ready. And then you get this user experience here, which is like being able to follow the deployment, and you see here that is done like one by one, and we are really close to have it finished. And the other thing that you can do is, like I said before, if you use like Commander in your project, you have this notion of platform services. So you can say, I want to deploy Kafka with this specific version. And basically, it will allow you to say, I want to have a Kafka cluster running in this project, and it will automatically deploy Kafka on all of these clusters that are part of this project. You don't even have to do that one by one. So let me go back here and see that it's now complete. So the next step in my demo is to deploy, oops, it's not there, to deploy Cassandra. And you see something different here. I specify -p not storage class Portworx SC. That means what? That means that it will create some persistent volume claim for Cassandra. And you see here, the first one coming there. You will see in the volumes here, in the persistent volumes, that they are all using the AWS EVS, but now this one is using like the Portworx storage. And if I go to Portworx here, again, I'll be able to get like in a few seconds, I'll be able to see the volume coming here. And it will be quite interesting because the name of the volume, so it will be shown when it will be created and bound. You see, and you see the volume has the same name as the PVC, and you see where it has been attached, in which worker it has been attached. So it's really straightforward also to link these, volumes and portworks and PVCs there. And again, if I want to follow the deployment of my Cassandra cluster, it's really straightforward. I just use the same plan status Cassandra and look at it until it's ready. So what I'm going to do now is that I'm going to deploy Minayo, this object storage cluster, because we need it for the demo. And this one is not based on Kudo. It's another operator that we are using. And you see, if I deploy it, so I use this file here, and you can go here and look at this Minayo instance. You see it's a kind Minayo instance compared to Kudo, where we have our own kind that's called instances.kudo.dev. So you can describe your Minayo cluster, but all these options are really pure Minayo options. It has nothing to do with the one you will have for Elastic, or nothing to do with the one you will have for another one. And you don't have like a way to follow a deployment plan like you do here. Like the only way you can do is that you have to go there and look at the pods and wait for them to be ready. So you don't really get the good user experience that you get with like Kudo here. Then what I'm going to do is just like going to replace the service that is service type cluster IP. It means that I can access normally Minayo only from another pod running on the cluster, and I will replace it by service type load balancer, which means that I'll be able to access this cluster from the external world, which will be needed here because in the demo I want to be able to access the pictures from my laptop directly. So that's why we use this service type load balancer. So then I need to just check what is the URL for Minayo. So that will be the URL I'll be able to access from my laptop. And we just need now to have the Minayo pods ready. And that will means that they will be all running 1.1. So currently when you see running 0.1, not ready, that means that the container is already running, but is not ready because it has not reached the stage where you can start to use it. And this is something you configure when you configure your stateful set or your deployment. You can define an else check that has to be performed, and until this is returning 0, it's not ready. So we just look for that to be ready. And when it will be ready, what we will do is that we will configure Kafka. So this is the Kafka URL of our Kudo Kafka. And this is the topic we want to use. And then we will create a bucket. You see MC is the command line for Minayo. Oh, it's already ready. So I just like already do this. I don't know if the service type load balancer is ready. So we also need to wait for that. Because when you do service type load balancer, like I described before, it means that the load balancer is deployed on AWS automatically. And you need that to be ready before you can obviously access your application. So we will create like a bucket with this command line. Then we will say we want an event to be generated in Kafka every time there is a new picture with a suffix JPG, and then you just look at that if the event has been configured correctly. And then here, what we are going to do is that we are going to update the URL of this Minayo host in our application code so that it will know how to reach Minayo. And this will become more clear when we go through the CI/CD phase. So it's just a preparation phase. So don't really bother much with that. It's not really important. The most important is really configuring Minayo and being able to have like notification in Kafka. And as I said, this is done in AWS. So if I go here on the same region where I have my convoy running here, and I look at the load balancers, where are they? Oh, I have to go in EC2. And if I go to load balancers here, I'll see that what time we are now, 2nd of April. So this is like the load balancer that is being created for me. And you can see that this is the min IO service. So you see the tags that are added automatically when it's created. It just takes some time just to be able to deploy it and then to be able to perform the name resolution. But it should be there in a second. And when it will be there, we'll be able to access it here. So let me just go through that quickly. So we still have to finish configuring here to be able to notify, but we have our Kafka here running, and we have like our Cassandra running and deployed on Portworx. And what we are going to cover just after is CI/CD. You know, what are the different options for CI/CD? What do I want to put in place? So we'll just probably wait for that. I'll be able to do that at the same time we do the CI/CD. That's not a big deal, so that we don't lose too much time. So why you need CI/CD? I think it's quite clear. Probably most of you guys have CI/CD in place. You want to accelerate innovation, to reduce time to market. You want to have like a better quality of code. You want to improve collaboration. You have many reasons why you want this automation. In the cloud, you can use something like AWS Cloud Pipeline, for example, but it's not only one service. I mean, it's like one code commit service, one code, you know, like one code builds that will build your images from your code, one code deploy service that will deploy it, the code commit that will, you know, you will manage your versioning of your application and so on. So like many different services that you will start to learn. And these are proprietary services. And they have like all different building strategy, each one, not the pipeline in general, like code commit, code build, and so on. For example, for the code build, you'll pay for the resources, the compute resources used for the build. The good thing is that it's per minute pricing. The bad thing is that it's expensive. I mean, like I did a comparison here. If I take one option and I look at what would be the equivalent EC2 pricing for this option, I would pay $0.2 per hour. If I look at the code build pricing for the same instance, then that would be 0.9. So it's like 4.5 times the price. So if you just run a few builds like per hour, then that makes sense because you just pay per minute. But when you start to scale and having a lot of teams using it, then you pay a lot more than what you would pay if you would have like stable compute. So that's a big issue you get with this approach. Cloud build from Google, again, equivalent of what you see in AWS. Again, the pricing is not very straightforward and is not cheap. Azure, we spoke about that quickly when we've been through AKS. And again, the pricing is not straightforward at the minimum we can say. It's proprietary and the pricing is complex. I mean, that's kind of the conclusion of when you look at these different services. They are really nice if you have no CI/CD in place at all, because you feel that you can just consume these services. But then if you start on AWS and you start to use all of these services, and then you find out that you have a better pricing from Azure, you cannot go because you are completely locked, you know, on this. So what you can do, and what you can do also for CI/CD on premise. Obviously, you probably already have CI/CD, like I said. You probably use something like GitLab CI or Jenkins, and you can use these for Kubernetes. It's possible to do that. It's something you can do, but it's not straightforward. Most of the time, at the end, you will run kubectl commands. It's not designed for that. So the pro for that, the good thing is that you can have the same platform for your VMs and for your containers, but you cannot take full advantage of what Kubernetes can offer you. The other option is that you look at options that are really designed for Kubernetes, like Tekton and Argo and things like that. But they are pretty new, and they don't have you don't have so much documentation compared to what you have in GitLab or Jenkins and so on. So people want to use them because they're really nice, but at the same time, it's not so easy to use them, and it's pretty new. So that's one thing. The second thing is that people want also to change a little bit the way they do CI/CD, and they want to take like what we call a GitOps approach. A GitOps approach means that you have your application repository with your code, like your Java or Python or whatever code, and you track all the modifications. But with GitOps, what you do is that you also have another repository where you define the way you want to deploy it. Basically, you will put in this repository your YAML that contain your deployment and ingress on all your configuration about the way you want to deploy it. And you will be able to version it as well. So you can have different people, like a developer who is responsible for managing this repository with the application code, another operator that is responsible for defining how to deploy it on Kubernetes. It can be the same person as well. It can be the same repository as well, but this is really the idea of having your application code managed in a repository and having on the other side your deployment code also in a repository. So what we did at D2IQ, we created something called Dispatch, which is based on Tekton and Argo, plus a lot of things to make your life easier to use CI/CD with GitOps, and with a full support for the full stack. So that's what we are going to do in the demo. Hopefully now I should have it. Yes. So now I should be able to configure that. So let me just finish that part quickly. So we can move forward with Dispatch. So what you have in Dispatch can be deployed in any cluster, but on Convoy it can be enabled as an add-on, and you see I have it here. So when you enable as an add-on, then you see here you can create your repository. You can create your secrets, like for my GitHub or my GitLab or my Docker Hub, so that you can use them in your pipelines. Or you can use the CLI. This is what I will do because it's just easier to automate. And what you get as well is that you get access to the Argo CD dashboard. So Argo is for the deployment part that will be responsible to take your GitOps repo, YAML code, and create the resources on Kubernetes. And Tekton on the other side is responsible for building your Docker container from your application code. So this is the CI, this is the CD. And this is the glue between both. So let me just do that. Good. So the first step here in the demo is that we are going to create a service account for our pipeline. And this service account will be the one where we will associate the Docker Hub credential, the GitHub credentials, and things like that. So I'm going to log in with GitHub with my username and token, and I will store that in this service account. Again, I could do that in the UI, it's just that in the demo it's faster to do that way. But whatever I do here, you'll be able to see it like being, applied here. You see, I just created the secret for GitHub, and you see it's just like reflected in the UI. So I continue. Here is just if I do git SSH, which I don't want to do, so I don't care. I do login on Docker here, just with the Docker commands. And then I associate my Docker credential with my service account again, like I did before for my GitHubs credentials. And then I also do the same for GitOps, so that I'll be able to have interaction between Argo and my GitOps repo. So these are all my credentials. So just like the setup, basically. From now, I didn't do any CI/CD. So here I'm going also to say, I will create my repository. I will associate my repository with my application code with dispatch. So what it's going to do is that if I go, this is my application directory, my application repository here. And if I go and I look at my webhooks, there is nothing configured. So that means that, oh, it's an old one that is still there. But if I go and create that will create a new webhook here. And I should be able to see it now there. You see I have my webhook created. So that means that it will notify my application anytime I have like a new change in my, every time I have a new change in my repo, it will automatically notify dispatch, so that it will be able to start the build process and so on. And then I have my GitOps apps that are like application on Argo. So currently you see I have no application in Argo, so it doesn't apply any configuration change, it doesn't deploy anything in production. So by running these 3 command lines, basically it will create my repository here. Again, in the dispatch UI, I can see all these things going on here. I can see the same thing I do in the command line. And in Argo here, I'd be able to see my apps in a second. Let's start again Argo here. Yeah, so you see I have my 3 applications here for my 3 microservices, but currently if I look at the object, I have nothing here. See, I don't have like, it didn't create like any object, any deployment. And if I do like a kubectl get pods, you see I don't have my microservices running yet. So the next step here is that I'm going to get my, set some variables in my shell, and I'm going to go through this dispatch file. So I'm going to do it now and just indicate my Docker ID and my GitHub ID here. And I will explain you how this file works and how we configure it. I'm just going to start it now so that the build process starts, because it will take a few minutes. And then I'm going to explain you what I just did here. So yeah, I think we are, yeah, we probably not have time to do the full things if I do that. So I will not go through this broken thing. I will show you that after, but I'll just use directly the right one. I'm just going to modify a file in each of my microservices just to make sure that it triggers the build, because otherwise if nothing is changed, it will not build anything. And I'm going to do a commit here and a push. And what will happen is that the webhook that has been created will notify Tekton. And here you'll see a pipeline run that will start. So this will means that the build has been started. So we just need to wait like for a few seconds. And you see here, I have like the test phase for the photo microservice. I have the build for the map and the build for Flickr. And I don't have the build for the photo yet, right? So if I look at this dispatch file here, let me show you here. What's nice is that the full CI/CD pipeline can be described by the developer in one file. You don't have to go like in GitLab or Jenkins to many different windows to configure everything. You can configure everything directly here from one file. So I say, this is my source repository where I am in my directory. I can use some meta languages. I don't know if you are familiar with things like PUE or Starlax, but you can use them so that you can do some for loops, for example. So I have 3 microservices. I don't want to define the resource Docker image for each of them one by one. I can do a for loop. So I can do like a for loop here, and this is the variable here. So I will have a Docker image map, Docker image Flickr, Docker image photo. Then I have my GitOps repo where I have my YAML code for the deployment. Then I have a test phase where my input is my Git repository. Then I have a build phase for each application. And you see, if the application is photos, then I have a dependency on test photo. That's why you see the build was not running yet for photo, because it has the dependency to run the test first. Then I have a deployment phase for each one, where my input in this case is the Docker image that has been just built before, and my GitOps repo. And then I can define actions. When there is a modification in the master branch, then I want to trigger the build and then deploy for each app, for example. So everything is defined that way. So now if I go to Tekton here, I see that the build on the map is finished, the build on the photo is finished, the test photo is finished as well. So the build Flickr has started, the build photo has started, has been done. And then what happens now is that I have this GitOps repo. So the GitOps repo is where I define how I deploy each of these microservices. So if I look at the map microservice, I define like my YAML, I want a deployment with 3 replicas with these environment variables. And I have the same, I have a service, I have an ingress. So everything is defined here. And you see the only thing that is missing is the image name. So the image name is not known yet because it is built by Tekton. So what happens when the build is finished is that there is this deploy phase that is creating a pull request for each microservice. And basically what the pull request does, it creates a YAML file from the template, and it indicates this Docker image that has just been built. So what I need to do now is just to merge these 3 pull requests. I can do that from the UI, but I'm a little bit lazy, so I'm going to do that through the CLI. So you see it just like merge each pull request. And what will happen at that time is that here, I don't know why my Argo like seems to be not really happy today. Interesting. I don't know if I have a network connection issue from home or not, but first time I got that. Let me try again, otherwise I'll just show you what's going on. Try again here. Okay, so we'll not, but let me check if it works still, even if I don't see the UI. Yeah, I have an issue with Argo. So I know that we are a little bit out of time, so I will not go through that in detail. I'll just show you what it is supposed to do, because this is the most important. So what happens normally is that you get something, I don't know what happened with Argo at that time, but you get something like that, and basically it detects that there is the new application YAML, and it just deploy like the full stack. And you can access the logs and things like that. And also, then you are able to go on the UI, and you see the pictures of this sunset and so on. So this is like just what should have happened. I don't know what happened with Argo, to be honest. And I don't have really time to debug it. The only thing I can probably do, let me just do one trial. Pods. Where is the Argo server? Where is it? It's that one. No, that one. Yeah, I don't know what happens because it didn't even restart. What did I do wrong? Delete pods. Just do that stuff here. Just trying to see if just restarting it works. Otherwise, as I said, we'll not spend too much time on it. First time I see that, and I've done this demo many times. Logs. Let's look at the controller as well, if there is anything now. Everything looks good. Where is my server? Should run soon. Looks like it's running. Okay, looks better. Don't know what happens. So if I do get pods now, yeah, I see that it has deployed my app here. So if I look at my app, and I can get the URL that way, then I should be able to see, you see all the pictures. And this is just the beginning because it just started. But after some time, it becomes really bad because you have many pictures at the same place, and you don't really see, which one you select and so on. So that's why there is a V2 of this front end that you can use, which is, oops, this one here. And the reason why I show you that is because basically I want to show you that when I will trigger this new build here, instead of building everything, it will just go and build what has just changed, which is the map microservice, because I didn't change anything on the other one. You see here, the build is only for the map. So it will be quite straightforward, and it will go through building this. And I didn't show you also before, what you see happening here is the description of the Docker build, basically. So you can really see what's happening behind the scene. What I didn't mention as well is that it report the status, but it also upload all the logs in a Minayo cluster that is dedicated for dispatch, so that you can still access all the previous logs from all the jobs you run for some time. So it's really important. because when you find an issue with your application, you want to be able to go back and look at how it was built, what were the messages when you built it, and all these things. So it's quite an important thing that happens here. And as I said, again, it's just like patch the do the deploy phase, where after having uploaded the Docker image, it's create a new pull request here that will come in a second. And what you will see is that it will again generate a new YAML file. But what will change from the previous one and this one now is just the Docker image. So I go here and I click on merge pull request. And what you can see if you go to Argo here is that Argo will find that it's out of sync because there is a new version now in the GitOps repo that we have just merged. So what will Argo do is that it will start to apply this modification. So you can wait for it to be notified, or you can just force it. We'll just do that to be faster. And it will discover that it has to do a rolling update. So what it does is that it creates the new version, the pods corresponding to the new version before it's terminated. So it does a rolling update, which means that you don't have like downtime in your application when it does that. And it's nice because you see, everything in the UI. You can even access the logs, of your applications instead of doing like a kubectl logs. You can directly go through that here. And we also support doing progressive delivery. I won't go through that now because it's probably a little bit too much, but basically with progressive delivery, you can say you can implement a service mesh with Istio, and then you can say, I want to introduce 20% of my new app and validate the latency. And if the latency is still good, then I want to go to 40% and so on. So we can do like a lot of very nice things. But now if I go back to my application, it should be a little bit smarter. And you see, instead of having like a lot of these things together, I can go and zoom and I can look at that just for Miguel. I do one for Lisbon here. So nice sunset from there. So yeah, I was a little bit out of time, so I didn't go through this version that I generally deploy first, which is broken. And the idea of this is that it allows you to see that to troubleshoot the issue, you can go on this Kibana dashboard that we have, that is part of the Convoy stack. And you could say, hey, I want to have like all the logs that correspond to my app here, for example. And you only see this, and then you can say, I just want the message part, for example. And you see here, you see all the logs, from the application that you see here. And you see at the beginning you had errors because the key space was not there yet, because the front end was trying to access the Cassandra database while the other the other microservices didn't create it yet. So, but that's a good transition for what we want to see after, which is the way you do you operate your platform. And we spoke about the logs. That's really important. But we also have to speak about the metrics. Okay, so what you want is that you want to monitor as many components as possible. That means the core Kubernetes services, yes, but that means you also want to be able to monitor your add-ons, like is my Elasticsearch cluster up and running and operating correctly? You want to be able to have some metrics for your storage system, for your data services. Is my Kudo Kafka working properly? Your CI/CD stack. So a lot of metrics you need to access and a lot of things you want to monitor. And we already discussed about, what's the user experience in the public cloud or in Rancher, and you've seen that you have some metrics, but it was really basic, like metrics about my kubelet or my pods, and that's it, like nothing about, all the other components we spoke about. And that's one thing. And the other thing is that when you're on premise, then you don't have this, so you have to build that yourself. And obviously you can look at the landscape, a lot of tools available for logs and metrics, but most of the people are using kind of the same, like they use these 4 things like Prometheus and Grafana for metrics and Elastic and Kibana for the logs. That's 90% of the people are using that. In Convoy, we spoke about the logs, and what we didn't show you yet is like one thing that people really love about Convoy is this Grafana implementation. So we have like these metrics about Kubernetes, kubelets, pods, volumes, a lot of things. But we also have the metrics for Elasticsearch, for example. How is my Elasticsearch cluster behaving? And we have backups directly integrated in Kubernetes with Velero. I can see the status of my backups so that I know if my backups of my Kubernetes configuration is fine. I can check like traffic, what is the status of my ingress? What is the traffic coming in my cluster? So a lot of nice dashboards, but we can go even further. You can say, I deployed like data services like Kafka, and when we create a new Kudo package, like we did for Kafka, we also provide you dashboards so that you can see your cluster. You have to configure, basically you have to configure metrics. It just reminds me that I missed this step. That's why we don't see metrics here, and we'll see them in a minute. So you have to create a service monitor, like you can see here. So you do that, and it will start to send metrics for Kafka. Anyway, I'll move forward and I'll show you that after. We have the same for Cassandra, and this time I configured it properly, so we should be able to see all the metrics for my Cassandra database here. So you see, if I go to overview, it just started here, you see, because I just started it recently, but it's the last 6 hours. So you can go to the last 15 minutes, for example, and you can see the write latency, the read latency. You can go even further, and I have Portworx, and I want to make sure my storage cluster behaves properly. And you can see that here because we created the service monitor. So this is my cluster and how it behaves. I won't import all of them, but we have dashboards for the volumes, for the nodes, for the etcd column that is part of Portworx. So you see that's the volume. So I can even look at each volume and see my performance and so on. There is also even dashboards for dispatch, about all the events we received, from the webhooks. We have like a dashboard even for Argo about, the number of applications we deployed and how many are LC. So you get all these dashboards here. And now I think even like Kafka should even be there. Yeah, you see now Kafka is up and running, and you see everything. So it's really important. Like you get all these metrics centralized, and it really helps you to operate your platform properly. And these are just like the dashboard I've just shown you, just in case. So we spoke about that. Like in day-to operation, it's important to consider centralizing the logs, centralizing the metrics. But one other thing that is quite important to consider is the data protection. Data protection can be done in 2 different ways. One is with Kubernetes itself. You want to protect your configuration that is stored in etcd, and we use Velero for that. And I've shown you how you can see the status of your backup in your dashboard. But also, you need to back up or protect your application. It can be through database dumps, it can be through snapshots, it can be through replication, it can be... There is no magic here. I mean, like data is still data. data on Kubernetes is still something you need to protect in one way or another. So the way we do it in this demo is that we use Portworx, and that's why we deployed like Cassandra on Portworx, is because we'll be able to use the snapshot capability of Cassandra. So the way we are going to do that is just like, first of all, we'll go to look at the current Cassandra database and look at all the pictures of sunset correspond to rows in the database. Like you can see here, I have 400 something currently. And you see it like it's continued to come, you know, 31, 33, because the microservice continue to gather new pictures. So what we are going to do is we are going to do a snapshot of it. So the first thing we do here is that we create what we call a rule. It's a Portworx rule that say you have to run the command node tool flush. And this rule say node tool flush. What it does, it just like says, please write to disk everything that is currently in memory, which is important to do before you do snapshots. And then you do this snapshot and you say, I want to snapshot all my Cassandra pods, and I want to execute this rule first, which is the rule that flush everything on disk. So then you can take a look at this to look at, I have my 3 snapshots now created, because I have my 3 volumes. I can see more details here. You see if I want to see the status of it and so on. And now that I have my snapshot created properly, what I'm going to do is that I'm going just to delete all my rows in my database, okay? I should have stopped my service that continued to gather new images, but I didn't do that. It's just like showing you a little bit about, you'll see that we will start to have new rows, but it's not very important. What we want here is just to show how you could do a disaster recovery or recovery from the snapshots. So I'm going to delete the instance. And you see it's interesting because a Cassandra instance or a Kudo instance is just like an object in Kubernetes. So I just use a standard kubectl delete instances Cassandra. And automatically, it means that the Kudo controller knows that it has to terminate all the pods for it, you see, and it's currently terminating all these pods. Now, let me just wait for that to be finished. Yes, I'm going to delete the 3 volumes, the 3 PVCs, the claims for these 3 nodes. And I want to restore for the snapshot. So just a loop that says restore for the snapshot. And I get the snapshots with this command here. And now if I look at my volumes, I'll see that I have new volumes, and they are not from Portworx SC, but they are for this special snapshots storage class. And what I can do now is that I can say I want to deploy Cassandra again with Kudo, but then I change the storage class and I specify the one from the snapshot. And again, I can just follow the deployment plan easily using like the kubectl Kudo plan status command. I can look at how it goes with the get pods, and I see the first one is already running. Second is being created. It's like one by one. What I'm going to do when it will be ready, I'm going to go back in my Cassandra cluster and I'll be able to check the count. It should be 433 or I don't remember, something like that, you know, depending on what we did. Even if it's not finished, I can probably already access it. No, need to wait for it to be finished. It will be ready soon. I can use the plan status until it's complete. It is complete. I can now access it. And I see I have my pictures back. I can just delete my map front-end pods so that they are recreated, because I developed this application very quickly. I could have done a retry when I cannot connect to Cassandra, but it just fails in this case. So that's why you were saying like this crash look back here. But when they will be running again, it will connect to the database that is back here. And at that time, I should be able to access it here again and see my pictures back. So again, really simple way to just show like data protection in action and how you can use Portworx and the benefits of using something like Portworx. But in any case, the most important message here is that you need to plan your data protection strategy here. And then, so we have Kubernetes platform, we have persistent storage, we have data services, we have CI/CD, and we have everything for data operation. What do you need to do now? You need to train your developers so that they can use it correctly. And at the beginning, there was only one certification that was called like CKA for administrators. And you see the red thing, it become more and more popular. And they started the CKAD for developers. And you see, you follow this, it follows the same trends. It goes really high now. And it's really important, I mean, like, because when you develop an application, and you will be involved also to troubleshoot it. So you need to understand, you know, how Kubernetes works so that you can troubleshoot it. But also, you need to understand the concept. If you are like in a DevOps approach, you are also responsible for the deployment. You then need to know how to deploy that correctly. And even just the way you develop your application, knowing how Kubernetes works is generally really, really important. So at D2IQ, we are certified by the CNCF to provide trainings for people to pass the CK and CKAD. So don't hesitate to contact us if you have like these needs. So at the end, with all these things in place, and what I didn't mention here is that we are certified to provide trainings to help you pass this certificate, and these trainings can be online trainings with an instructor or on site. So really, we provide the two options. So now we've gone through all these different steps. If we look at the different products we have presented in this workshop, we spoke about Convoy that allows you to have like a Kubernetes cluster easily deployed on-premise or in the cloud. We've discussed about Kudo if you need to run some data services on top of Kubernetes. We spoke about Commander that allows you to do like this multi-cluster management, deploy additional cluster, manage permissions. We spoke about Dispatch if you want to have like a modern CI/CD stack. And we spoke about our training offering. What we didn't speak about is DCOS, but just wanted to highlight, you know, the way we position our products and the way we position DCOS in front of like other things like Convoy or Kudo. By the way, DCOS is really for everything as a service. If you want to run Kafka on Kubernetes, then you have Kudo. But if you want to provide Kafka as a service for multiple business units so that each business unit can have its own Kafka cluster, if you want to run that bare metal, then this is DCOS. If you want big data, this is also where DCOS really makes sense because you can deploy HDFS as a service, you can do like Spark as a service, Jupyter Lab as a service, NiFi as a service, all these things. And now, when you see this full portfolio, it probably makes more sense for you why we change our name from Mesosphere to D2IQ. Mesosphere was really just this part, and anytime people were associated Mesosphere with Mesos, with DCOS, so we decided to change the name so that it reflects what we do now, which is still do DCOS, still have a lot of happy customers here and a lot of traction, especially on the big data side. But we also now have an option for people who want just to start with a small Kubernetes cluster or several Kubernetes clusters, and they want to grow, run data services on that, manage multiple clusters together, and so on. And day 2 IQ means day 2 operation, and IQ is like intelligence quotients. But it's not very important what it means because, I mean, it's in the future, day two operation will probably not be as popular as it is today, but still it will be like a D2IQ, like a company name like EMC or IBM or whatever else. Also, one thing that is really important is that in our portfolio, we do a lot of testing at scale. And we've done that with DCOS since a long time. And we now do that with Convoy and the full stack on the Kubernetes side. And you see, we are already at a scale where we test Convoy with 275 nodes, with GPU. We run like thousands of pods and hundreds of Jenkins instances. We run like Terraform. Thing is missing here. I will put it here. No worries. So normally it's Jenkins here. Like these are the number of masters and executors. We run like Kafka clusters, Spark jobs, Cassandra. A lot of writes. Use 260,000 writes per second Cassandra. Millions of messages per second on Kafka. Everything in parallel, everything together, just to make sure that everything scales and works well in production. And just wanted to go back to this cloud native trail map that we discussed at the beginning of the workshop, because wanted to highlight with you that we have covered a large part of it. We cannot cover everything. We've covered a lot of it. We also have like Calico if you want to have like network policies in the stack. We also have like traffic and Istio to cover this part on Convoy and Commander. One thing I didn't cover in this session, because it's really not in our, it's not a specialty on D2IQ, is security. So for security, we simply work with partners. You have really good companies there, like Aqua or Twistlock, for example. So we don't try to provide solutions in this area because that's not our expertise, and there are people there that do that really well and that are good partners of us. Just wanted to finish by that, highlighting that, and a big thank you to all of the people who joined this webinar. And it has been recorded, so you'll be able to watch it again or provide that to some of your colleagues if you found, hopefully, if you found it interesting, and or if you have not been able to join. So thank you very much. I don't know if on the PUE side you want to say a word at before we end it. I think we are just on time, so quite happy about the timing of it.
Muchas gracias a todos. No hemos tenido ninguna pregunta. No sé si había preguntas, si había cosas que querían comentar. Pero bueno, estamos disponibles. Pueden enviar a PUE, como le han comentado. Había un email, no sé si lo han visto todos. Había un email que es, perdona, no me recuerdo. Abraham, sí. sales@pue.es, sales@pue.es. Pueden enviar vuestras preguntas si algo no le ha parecido claro y podemos asistir los que quieren si hay más preguntas. Thank you, Denis. Thank you, everyone. Thank you, PUE, for organizing it. Abraham, I don't know if you want to say something, or Lucia, I don't know. No, that's okay.
Thank you very much.
Thank you so much.
Thank you, Denis.
Take care with this difficult period. We hope that everything is safe and healthy. So take care of you guys. Bye bye.
Sí, queden en casa, sí.
Gracias a todos por participar y nada, os esperamos en el próximo Tech Day. Cualquier duda o consulta estamos a vuestra disposición. Que tengáis un buen día.